All right. 1C asks, at what time t, in the interval 0 to 8, is the amount of water in the pipe at a minimum, and justify your answer. So in order to find a minimum, we're going to find a critical point for the amount of water in the drain pipe. We know that to find a critical point, we set the derivative or the rate equal to 0, or find where the rate is undefined. And then we can also consider the two endpoints 0 and 8. So let's go ahead and do that. So the rate is going to be the amount flowing in minus the amount going out. So the rate is going to be R of t minus d of t, and we figure out where that is 0. Easiest way to do that is to go to the calculator, graph that. So I'm going to do 20 sine of x squared over 35 minus this function, negative 0.04 t cubed, or x cubed in this case, plus 0.4. I probably should put parentheses around all of this. Let me fix that. (0.4x squared) plus 0.96x. And I need to go from 0 to 8, so I'll go straight to the window and change my minimum x value to 0 and maximum x value to 8. If I want to, if I'm having trouble seeing it, I can sort of squeeze these closer. I'm just going to leave them at negative 10 and 10 for now, but I might need to come back and make it like negative 1 and 1. It'll be easier to see where the zeros are that way. We'll graph this, and we see it starts off being negative, goes being positive, and is going to come back. Okay, so let me see what happens here. This is the rate of change. What this means is we start off draining water out of the drain pipe because the rate's negative. When we hit the 0, at this instant, the rate of change is 0, so it's not really filling up or emptying out. And then afterwards, the rate is positive, so it is filling quicker than it's emptying. So I just need to figure out where this is. So I can do second calc, 0, go close to my 0, and pick a point that I know is left of that. So I know this is left of my 0. I can see that this is negative here, so I've gone past the 0. Pick a point to the right of my 0. I know that's right of my 0 because that's positive. And then pick a close that's a guess that's as close to the 0 as I can. That's pretty close. And it tells me that this happens at approximately 3.272 hours. So let me write that down there. T is approximately 3.272 hours. Now, I know from here, because it is negative ever in that interval before and positive ever in that interval after, that this must be the minimum in that interval. But if you want to be sure, you can check every possible extreme in here, and that's going to be at 0, here, and at 8. So I'll just check all of them, and the way to do that is I'm going to do the integral from, I guess, 0 to 0 of r of t minus d of t dt, plus that starting value, which is 30 cubic feet. I'm going to check the integral from 0 to this value, 3.272, of r of t minus d of t dt plus 30. And I'm going to check what happens at the very end of the interval, 0 to 8, of r of t minus d of t dt. plus 30. And so in here, I can do that pretty easily in my calculator again. This is already r of t minus d of t, so I can just do calc integral. And of course, 0 to 0, we know that this here is going to equal 0 plus 30, so I don't need to put that one in. There's no area in here if the lower limit and upper limit are equal, so this is going to be just 30 cubic feet. But this one I need to consider, so let me actually put that in. So from 0 for the lower limit up to 3.272. And if I want to know how much was in there, I'd keep extra units here, extra digits, but since I just need to know the time, this is already rounded to 3. This is going to be my final answer, so I don't need to keep extra information there, but I should have if I want to know the quantity in there. Integrate this, and I get that integral, which is going to be approximately negative 2.035, so that's negative 2.035 plus 30, which is going to be approximately 27, let me do that math, 0.965 cubic feet. And then if I go back here and do that integral from 0 to 8 to get the entire, the sort of ending value, it'll take a little bit to figure out that area. That will tell me how much is in it. You have the integral of the rate plus the starting value will tell me the ending value. That was 18.544, which means that this is going to be approximately 48.544 cubic feet. And now I can go back and say, okay, that's the smallest. We can see it's smallest all over this interval. So we reach a minimum at t approximately equal to 3.272 hours because the rate is negative for t in this interval from 0 to 3.272, approximately. So t in that interval. And the rate is positive afterwards. So 3.272 all the way up to 8. So this is sort of the first derivative test. If I go from having a negative derivative to a positive derivative, I end up at a minimum.